All right, ladies and gentlemen, so today we're going to talk about lesson 4.2, which is writing equations in slope-intercept form. And again, you're going to have Bitmoji me instead of a video today. First thing is the skills that we are working on. Just like before, we're going to continue to work on writing a function that describes a relationship between two quantities, and we're going to talk about constructing linear functions using sequences, given graphs, a description, or input-output pairs. So we're going to take different types of key information to write our equations today. So first thing, we have two vocab terms to define in our notes. The first one is the idea of a constraint. A constraint is the condition that the solution must satisfy. The solutions of the equation must meet the constraints of the problem. So this is how we are limiting our solution set. The next vocab term is the idea of a linear extrapolation. Linear extrapolation is the process of using a linear equation to make predictions about values beyond the range of the given data. So if I have a graph and I know when x is 1, y is 1, when x is 2, y is 2, well, I can connect those dots and make a line and use that to extrapolate, to find data outside of that set. Like when x is 4, I can extrapolate that y will equal 4. So there are three steps that I'm going to need to follow when I'm writing equations in slope-intercept form from key information. The first thing is to find the slope. Sometimes I can find the slope because it'll be given to me, and so I can just point on the page, my slope is whatever. Sometimes I might have to use a slope triangle. If I have a graph, I can take that idea of change in y over change in x to find my slope. Or if I have ordered pairs, I can use the idea of my slope formula, where y2 minus y1 divided by x2 minus x1 gives me my slope. Once I know my slope, I'm going to find the y-intercept. And again, there are many different ways that I can find that y-intercept. Sometimes it'll be given to me. Sometimes I'll need to look at the graph and figure out where my line crosses the y-axis. But the third situation is what we're really going to be practicing today. If necessary, I can substitute in the slope for m and one of my ordered pairs for the corresponding variables in the equation y equals mx plus b and solve for my unknown piece. Once I have my pieces, I know m and I know b, I can write my equation in the form y equals mx plus b. So let's practice with this. That's a lot of words, but it's a concept that you should understand. So first, let's try it. If I give you a point and a slope, while thinking about my steps, the first thing I need to do is find the slope. All right, I found it. So my m value is -3/4. Well, now I need to find b. I need to know what that y-intercept is. To do that, I'm going to think about that second step, the if necessary part. So I'm going to start with my generic y equals mx plus b, and I'm going to plug in the pieces that I know. Well, I know m, and I have an ordered pair which tells me an x and a y value. So I can take that x and y value and plug it in. I have y is 4, and that's going to equal my m value of -3/4 times my x value, which was 6, plus, I still don't know b. I have an unknown piece, so plus b. Well, now all I need to do is use my equation solving skills, and I get 4 equals -3/4 times 6. Well, that's going to be -18/4, which is simplified to -9/2. Well, I want to take that and turn it into a decimal. -9/2 is the same as -4.5 plus b. I can leave it as a fraction, but because I know what's coming next, I know that using it as a decimal is more useful in this situation. I'm trying to get b by itself, so to get rid of this piece, I'm going to add 4.5 to both sides. And I get 8.5 is b. So now I can go back to my original spot here, and I have b is 8.5. The last step that I need to do is I just need to plug back into that idea of y equals mx plus b. So my final answer is going to be y equals my slope of -3/4 x plus my y-intercept, 8.5. I can take a point and a slope and write my linear equation. Well, now what if I have 2 points? First thing I need to do, same as before, is I need to find the slope. But in this case, I'm going to need to use the slope formula. That slope formula tells me y2 minus y1 over x2 minus x1 y2 minus y1 over x2 minus x1 is my slope. So what I see here with my ordered pairs, I'm just going to label my pieces. I have x1, y1, and I have x2, y2. So I'm going to write that out in my giant fraction. I have y2 minus y1 over x2 minus x1. Well, minus and negative is the same thing as addition. So I find that my slope is 3/2. Well, now I need to find my b value. To find my b value, I'm going to do the same thing I did over here. This time, I'm going to take my slope and one of my points. And I can choose either point. But because I'm an 8th grader and I'm scared of negative numbers, I'm going to choose the second one. It's easier to not get lost if we have only positive values. So again, I'm starting with that idea of y equals mx plus b. And I know my y value is 1. My m value is 3/2. My x value is 7. And b is my unknown piece. Well, now solving my equation here, I have 1 equals, well, 21 over 2, that's the same as 10.5, plus b. To get b by itself, I need to take away 10.5 from both sides, and I get negative 9.5 is b. So I have 9.5. Now I just need to pop my pieces back into my original equation, and I find out that I have y equals 3/2 x minus 9.5, or plus a negative 9.5. My negative sign kind of got lost there. There's still a negative there. Beautiful. I can find my linear equation when I'm given 2 points. One last problem to practice with, and this one is off the worksheet. If you flip it over to the back where it has that big chart, number 11, I give you the y-intercept and a point. So it's similar to finding a point and slope, but let's look at this here. What am I given? I'm trying to get to that idea of y equals mx plus b. What I see here is that I have my b value. My y-intercept is my b value, and I have an x value and a y value. So again, this is kind of like solving a puzzle. I'm given 3 of my 4 pieces, and I need to figure out how I can find the missing one. So y equals mx plus b, well, that's going to turn into 8 equals m is my unknown piece times my x value plus my y-intercept of -1. Now, using my equation solving skills, I know that I'm going to add 1 to both sides to get rid of it. And I have 9 equals m times 3, or 3m. To get m all by itself, I need to divide both sides by 3. So I find out that the slope is 3. So I have my intercept, I have my slope. All I need to do is plug them back into my equation. So y equals 3x plus a -1, or -1. I can take the pieces that I'm given and solve for the missing value. Well, now what we're going to do is we're going to take a look at this idea of triangle lines. A triangle consists of 3 line segments. A segment is a portion of a line. So if you look at your worksheet now, we're working through that exploration activity on the front side. So what we want to do first is we want to find the equation of a line that contains AB. Now in this case here, again, I'm still searching for slope and intercept. Let's do our intercept first. Because I have this on a graph, it's easy to see. I can tell that I crossed the y-axis at the value of 6 for y. Now to find my slope, I can use a slope triangle, or I can use the slope formula. I want to use a slope triangle because I like doing things visually, but either way should work. So let's draw in a little slope triangle here. I need to find integer values for my x and y, so spaces where that orange line crosses the grid lines. So let's take, well, we can draw the slope triangle all the way from A to B. That'll work. And when I see my slope triangle here, I see a change in y. Well, y goes from 5 to 8, so that's a change of 3. My change in x, well, I see a change from -2 to +4. That's a change of 6. Now I just need to pop that into my fraction over here. Change in y over change in x is 3 over 6. Well, I can simplify my fraction to 1/2. Now I'm going to write the equation of the line. Again, I'm just going to plug the pieces in that I know. Y equals my slope times x plus that start value plus my y-intercept. Well, now let's do it again for the line that contains AC. So first things first, I'm going to try to find my slope and intercept. And again, I'm going to circle that intercept. I see I cross the y-axis at y equals 4. For my slope, we'll draw in a nice big slope triangle again. Connect from here to here and here to here. And I see a change in y. I go from 5 to 2. Well, that's a change of 3. And I have a change in x from -2 to +4. Well, again, that's a change of 6. This one, though, that I want to think about is that change in y was really a -3. I have a downhill slope. So this time, my slope looks like -3/6, which simplifies to -1/2. So the equation of my line is y equals -1/2 x plus 4. Well, for my last line here, I don't cross the y-axis. I have a vertical line. This is not a function, but I can still write an equation for this. What I see and what I should know by now is that anytime I have a vertical line, my equation looks like x equals a number. Well, in this case here, x is always 4. No matter what value I have for y, x equals 4. So my line equation looks like x equals 4. So now let's think about Ryan and Ryan's triangle here. Ryan made his own triangle. He chose 3 points and wants you to find the equation of the 3 lines that make up his triangle. His points are Q, 3, 3, R, -2, -7, and S, -7, -2. Find the 3 linear equations that intersect to make his triangle. Well, to do this, and as you see on your worksheet, we're going to break this up into 3 steps. The first thing we want to do is we want to find the line for QR. QR. To do that, I need to use the slope formula. I'm going to rewrite my 2 points underneath this here just so I've got it ready to go. Q was 3, 3, and R is -2, -7. So I want to think about x1, y1, and x2, y2, and I'm going to use the slope formula. Hopefully we got the slope formula up here just so we've got it ready to go. y2 minus y1 over x2 minus x1. When I plug in my pieces, I get -7 minus 3 over -2 minus 3. Well, -7 minus 3 is a -10. -2 minus 3 is a -5. So I know that my slope is going to be, well, negative over negative. My slope is +2. Halfway there, now I need to find my y-intercept. To find my y-intercept, I'm going to take my slope and 1 point and plug it into that generic form of y equals mx plus b. And I could choose either point, Q or R, but I'm going to choose Q because it has positive values, and that way I can't get lost with my negative signs. So I have 3 equals my m value of 2 times my x value of 3 plus my unknown piece. This turns into 3 equals 6 plus b. Take away 6 from both sides, and I get b is equal to -3. So the first equation is going to look like, we'll write it up at the top here just so we can squeeze it in. Y equals 2x minus 3. Now I want to think about my next line. I have line RS. Well, again, I'm going to rewrite my ordered pairs. My ordered pair for R is -2, -7, and S is at -7, -2. I'm going to use the slope formula. I want to think about x1, y1, x2, y2, and I'm going to plug them in. I get -2 minus a -7 over -7 minus a -2. Minus a negative is really the same thing as addition, so I get -2 plus 7, which gives me 5, over -7 plus 2, which gives me -5. Well, in this case, my slope, 5 over -5, simplifies to a slope of -1. Halfway there, now I need to go back to y equals mx plus b, and this time I have negative values in all of mine, so I can choose either point. Let's choose this one here. We're going to choose R, and that tells me that -7 is equal to my x value of -2 times my m value of -1 plus b plus my unknown piece. So I get negative 7 equals 2 plus b. Take away 2 from both sides, and I find out that b is equal to negative 9. With my two pieces, I'm going to plug them into the equation, and again, we'll write it up here at the top. I get y equals negative 1x, or negative x, plus a negative 9, or minus 9. One more equation to work through. We need to find the line between q and s. So we'll do qs here. The ordered pair for q is 3, 3, and s is negative 7, negative 2. Slope formula, I want my x1, y1, x2, y2. When I plug that in, I get negative 2 minus 3 over negative 7 minus 3. Well, that turns into negative 2 minus 3 is a minus 5. Negative 7 minus 3 is a minus 10. So my simplified slope, negative over negative tells me positive. 5 divided by 10 tells me 1/2. In this case here, my simplified slope is 1/2. Last thing I need to do is I need to find my b value. I'm going to go back and plug into my original y equals mx plus b. And again, this time I'm going to use q because it has positive values. So I get 3 equals 1/2 times 3 plus my unknown piece. Well, that turns into 3 is the same as 1.5 plus b. Take away 1.5 from both sides, and I find out that b is 1.5. I've got my two pieces. I can write my line. Y equals 1/2 x plus 1.5. All three lines here. Well, now I want to think about step 5. The points where the line segments meet in a triangle are called the vertices. Graph your 3 lines using the slope and y-intercepts from your equations. Does the triangle that is formed have the same 3 vertices that Ryan chose? Check using the coordinate grid. So you're going to be graphing this on that tiny piece of graph paper underneath line QR, but we are going to practice it on this next page, and the lines aren't going to pop up, so I'm going to have to use my notes here. So the first equation that we were looking at, our line for QR was y equals, let's do this one in red, y equals 2x minus 3. So the first thing I need to do to graph this line, I find my y-intercept of negative 3 and I put a dot. A slope of 2 tells me up 2 over 1. And I'm going to do one more dot just to make my line easier to draw. Up 2 over 1. And I'm going to draw a line across the page as straight as I can. This is really hard on a touch screen. All right, that's not going to give us the best work, but we're going to roll with it. When you are doing this on your worksheet, you should be using a ruler. That'll help you get better lines than what I have here on the page. My line for RS was y equals negative 1x minus 9. So again, I'm going to find my y-intercept of negative 9. And a slope of negative 1 tells me down 1 over 1, which is the same as up 1 backwards 1. So I have a nice line that's going to go like this, sort of. And the third one, my line for QS, looks like y equals 1/2 x plus 1.5. Now this one here, I'm going to have to be really careful to estimate. 1.5 for my y-intercept is somewhere around there. And then a slope of 1/2 tells me up 1 over 2. Up 1 over 2, somewhere around there. And we're going to do our best to sketch the line here. Something like that. When I look at these 3 places where my lines cross, that's where those are my vertices. And so I want to see if my vertices match or if they even come close to what I should have found. Well, if I look at this here, this one, if I had nice straight lines with my ruler, should have been at 3, 3, because this should be point Q. It's close. My graph is not very accurate on my screen here. My next spot should have been about here at negative 2, negative 7. And again, it's close, but my graph is very messy on the screen here. So that one should have been point R. And my last one at -7, -2 should have been S. I was close. If I had a ruler, and if you look at my example that I'll post on Teams, I used a ruler and we were accurate. Graphing is tough because you need to be very precise. So now your job is to finish up that worksheet. When you're done, make sure you take pictures that I can read and submit it on Teams. But you're halfway done already. We already did the explore side. Your job is to finish up the, let's see, 11 more of the worksheet problems. If you look at the page, the last one in the box is a challenge that you are required to do. The one at the very bottom that says extra challenge is bonus points. If you want to complete that one, you will need a piece of graph paper, or you can do it using algebraic skills. Explain it and tell me about it if you want to do 2 bonus points on this homework assignment. Thanks, guys. Make sure that you get this done and submitted.